Hello everyone, welcome to our lesson on transformations. Today we're going to look at transformations of a quadratic, but the rules are the exact same whether we have a quadratic or if we have a different kind of polynomial, or whether we are using logarithm functions or exponential functions, whatever. The rules apply and are the exact same. So let's get to it. If we have a function f of x equals x squared, we all know what f of x equals x squared looks like if we drew it. It looks something like this. Now if we changed our function to f of x equals x squared plus 3, there's a transformation that's happened. What did this plus 3 do to our original function? Well, what we say is that it's a vertical translation. The function has moved up 3 spaces. So before it was at 0, 0, now it's at 0, 3. That's your minimum point for your function. Instead of x squared plus 3, if I did x squared minus 4, it would mean the function went down 4. And now your lowest point would be 0, negative 4. The next function we're looking at is the horizontal translation, and this is when you're shifting it left and right. Just note, it is the opposite of what the sign says. So you've got x minus 3 squared. What that does to your function, it actually moves it to the right if it's minus. So for this one, we've moved it to 3, 0. If I had put x plus 2, it would have shifted to the left by 2 spaces, and I would have been at negative 2, 0. The next transformation we're looking at is the vertical stretch. What the vertical stretch does is you've got the original function y equals x squared. What the 3 does is it makes your function go up 3 times higher. And your function will look something like this. So if this point was 1, it has now gone up to 3. If this point was 2, it's gone up to 6. The next function we're looking at is the horizontal stretch. Now people get confused between the horizontal stretch and the vertical stretch, but they are different. If you notice, if we had 3x squared and 3x in bracket squared, the second one is actually equal to 9x squared. How this function works is if you had an original function like this of y equals x squared, what the 3 does is it pushes everything in 3 times. So if your x value here was 1, it's now changed to 1/3. If your x value here was 3, it's been pushed into 1. So once again, it looks like it's getting skinnier and the slope is getting steeper, but the vertical stretch is different than the horizontal stretch. The next transformation we're going to look at is a reflection on the x-axis. If the negative is on the outside, what it does, it changes your function from this. Now we're going to be reflecting on the x-axis, and it's upside down. And the last function we have is a reflection on the y-axis. For a quadratic, it doesn't look too special, but what you are doing is this is now going to be reflected on this line, on the y-axis. So all of this is now going to be on the other side, which just happens to be the exact same. There would be more of an effect if we were looking at a cubic function or some other kind of function. To learn these functions, we're going to need to do a lot of practicing, combining different kinds of transformations in one. For instance, what happens if you had f of x equals 3x squared plus 2? And we will work on that in class. Have a good day.